couple of questions that came up in linear algebra class, but they might well be applicable also to the calculus 3, the multivariable calculus. Question about the triangle inequality. Triangle inequality says that basically the shortest distance between 2 points is the straight line. Now, if you go from here to here via some point that's not on the straight line, you do that with a vector here and a vector here. Okay? And you can calculate the magnitude of this vector and the magnitude of this vector so that you know what these numbers are. And you can calculate the magnitude of this vector so you know what this number is. Very straightforward. Okay, well, let's do that. Let's say that A is a vector 2i plus 4j, and B is a vector negative 5j minus 7k. Now you should probably try to visualize where these are in the three-dimensional space. 2i plus 4j, if x is this way, y is this way, and z is this way, it's 2 this way and 4 this way, so it's kind of in this direction. Okay. The negative 5j minus 7k, well, the y-axis is this way, you're going to go 5 in this direction because that's negative 5j, and then 7 downward because that would be negative 7k, so it'd be this. So you got this vector here and this vector here. Now if you start here and go down here, start at the initial point of your first vector and go to the terminal point of your second vector, you have a straight line and you formed a triangle that doesn't necessarily look like this. It would actually be a right triangle. So in any case, and if it's a right triangle, it should have come out differently. What if I did something wrong? Can't imagine. No, shortening the j. Yeah, actually my k vector was in this direction down here, like this with this. Okay, well, let me anticipate the fact that you could have a hypotenuse that's shorter than one of these vectors, or maybe even either one, where if this is A and this is B, and here's your A plus B, okay, this vector is pretty short. Now you can ask yourself, could I draw 3 vectors where A plus B is shorter than either A or B? Turns out that it's pretty easy to do that, so you might try that. Again, also try to visualize where this is in three-dimensional space. Preferably sketch it out as best you can. Learning to sketch in 3 dimensions is an art. I certainly haven't mastered it, but I've got some practice. Okay, so anyhow, we're going to verify this. Okay, well, we need magnitude of A. Well, that's easy. The magnitude of this vector is square root of 2 squared plus 4 squared, which is square root of 20. Magnitude of B is easily calculated. You square 5, you square 7, add them up, take the square root, just the Pythagorean theorem, you get square root of 74. A plus B, well, you got 2i here, no i's here, so you get 2i in your sum. You got 4j and minus 5j gives you negative j. No k here, negative 7k here, you get negative 7k. And you do the square root of the sum of the squares of the components, and you get the square root of 54. Then you write out what the triangle inequality says, and you get square root of 20 plus the square root of 74. It has to be greater than or equal to the square root of 54. That verifies it, because of course square root of 74 is already bigger than the square root of 54. Now sometimes you actually got to do the arithmetic on these things, and you do want to be careful. You can't add the 20 and the 74 and do the square root. That's not equal to the square root of 20 plus the square root of 74. Okay, square rooting doesn't distribute over addition. Okay, another question that came up just regarding some simple vectors. How do you do 3 times a vector? Okay, because there's something on homework where somebody had to do 2 times a vector and they messed it up, got confused. First place, it's good to sketch them. I didn't do that, but it's always good to sketch the vectors. In 3 dimensions, sometimes that's a little bit hard. So let's just do 3 times the vector a plus b. We've already calculated the vector a plus b. Here it is. So I've written it here with a 3 out in front of it. Okay? Distributing this 3 through the multiplication, we get 6i minus 3j plus 21k. Alternatively, we could have written our a plus b vector, 2i minus j plus 7k, as 2, negative 1, 7, ordered triple with an arrow over the top of it. Okay? And then we multiply through by 3, and we get 6, negative 3, 21, agreeing with the components we had when we wrote it out in terms of I, j, and k. Now, we could also do 3 times a plus b by distributing the 3 multiplication by 3, we get 3a plus 3b. Well, here's a multiplied by 3. Here's 3 times the b vector, our original a and b vector from over here. We do the multiplication. 3 times the a vector gives us 3 times 2, 6, 3 times 4 is 12, 6i plus 12j, and 3 times negative 5j minus 7k is negative 15j minus 21k, and then we just kind of collect things. We've got the 6i, there are no other i's. There's a 12j and a minus 15j giving us a negative 3j, negative 21k. This is identical to this and equivalent to this.